Good afternoon, everyone. SICKI, jointly with FAME TN, is organizing this webinar on scope of Industry 4.0 for MSMEs. As a beginning, I request Mr. M.P. Subramanian, Senior Board Member of SICKI, to deliver the welcome address, please.
Thank you, Bhavani. It is my pleasure to invite Frank and all the SICKI members or the participant in this event. Probably I have to set the context of what SICKI was trying to do and what my views on probably this Industry 4.0, why it is so prominent and why it is important for MSME to adapt. As we are aware that we started this journey of introducing this Industry 4.0 concept to MSME even 2 years back. I being in the investment space, now I see so much of activity in digitization in supply chain, and even the country by itself have actually made so much of infrastructure built digitally, right from GST to what has happened in the ecosystem through the India Stack, everybody is aware. And the next big revolution which is happening is in the supply chain and financing. All these are very, very interesting to see how the ecosystem by itself have changed externally. Now, when it comes back to the looking at what is happening within the industry, within the areas which we operate, there is a kind of a gap which we see in most of the places. The one is, if you look at a kind of companies which has come in, tracking and tracing assets, there are many companies which has come in. There are companies which is there for building management to manage the what you call operations of the building to minimize the cost. You take anything in this space, it is growing rapidly. And many of us are used to this, some of this digitization which has happened. But only thing which was pretty slow in my view and which has to be adapted much more faster. The whole external ecosystem have already changed. And to take the benefit of this change which has happened in the external ecosystem through digitization, it is important that we have to look forward to find out how we can modernize our operations within the within our ecosystem, within our company, within our organization, by adapting or retrofitting or adapting the whatever the concept which has been brought by the Industry 4.0. There are areas which has been touched by many organizations, many early stage companies and startups. There are research going on in other places, and this is becoming very important for us to be relevant and for us to look at how our product and our service is going to be very competitive in the external world. And you are aware that when the people were not being able to adapt the changes which has happened in the GST world, they have to close the organization and go. This is because of the pressure of the external input. Now it is up to us. We have sustained and we wanted to make sure that we are operationally benefited and we have to be competitive in this external world. This is becoming much more relevant, much more important for us to adapt. You name any of the operations within the organization, everything is going to be digitized in some point of time or other. Even if you have invested large sum of money, there are technologies which is supporting to retrofit some of this what you call digital solutions, which can help us to make sure that we are also part of the Industry 4.0 revolution. Actually, we are moving from Industry 4.0 to away from this. Many of them have started moving it. At least India being a larger country, and we are benefited by some of this digitization, we should be able to look at what the practices available across globe and make sure that we adapt in our industries for the benefit of what we do. I leave this thought here. I welcome Mr. Frank, who has accepted because of Ram. I also thank Ram for making sure that Mr. Frank is there for us to share his views and then give us opinions on how things have changed. I have to leave a note with Frank saying that Frank, India being 80%, world over 80% MSME is what driving the economy. India being the, what do you call that? India adapted the digital changes externally very well. Government is pushed many of those things into digital thing. Government is pushing supply chain into, you are aware of India Stack, and then ONDC is something which is going to come. Probably when we are ready and if you are able to give examples of how the organization which was old enough adapted to these digital changes, and then making sure that some examples can help them to appreciate how these changes can help them to be operationally efficient, it will be very helpful. I leave the webinar here. Probably Ram can introduce the Frank about who is he and how he is representing this gathering, who are all entrepreneurs here, who have done this, what do you call that, industry for so long, and they would like to hear from Mr. Frank, what are the areas in which it will be helpful. Thank you. Up to you, Ram.
Thank you. It gives me immense pleasure in introducing Mr. Frank Schnicker, who's from Fraunhofer Institute of Experimental Software Engineering, Fraunhofer IESE. So Fraunhofer IESE is part of one of the 76 institutes of Fraunhofer Society. Fraunhofer is Europe's largest application-oriented research organization. It was formed in the year 1949 throughout 76 institutes throughout the country, and with about 29,000 employees, mainly scientists and engineers, and with an annual research budget of about 2.9 billion. And that's how large they are. And it's the biggest organization for applied and research. And in that, for IESC, they specialize in Industry 4.2, and I got the opportunity to meet them in the one of the exhibitions a few years back in Germany. And there they show the importance of Industry 4.0 and how easily it can be implemented through various softwares, open source modules and all. To lay the context of the webinar, this would be a long-term relationship starting from this webinar. The main issues India faces in Industry 4.0 is we are not able to match the global standards, or we're finding difficulty in matching the global standards, the customizations in pretty short in small lots. The transition to Industry 4.0 is a remedy to this. The flexibilization of the production process enables fast and cost-efficient change of product types. Fraunhofer IESE focuses on digital ecosystems, dependable AI, digital twin, system modernization. So henceforth, I'll leave the floor open to Mr. Frank Schnicker. Over to you, Mr. Schnicker.
Thank you very much for the nice introduction, and thank you very much for having me. It's a great pleasure and a great honor being able to speak for so many companies in your great country. Before I start, are you able to see my screen?
Yes.
Perfect, great. Okay, so as already being told in the nice introduction, Industry 4.0 offers a plethora of benefits, like, for example, cost reduction, quicker time to market, and just to put it in a nutshell, overall increase in revenue. However, Industry 4.0 as a, let's say, as a term is very broad, and implementing Industry 4.0 can be very daunting, especially for SMEs. But let's say the good news here is that it does not need to be hard. There are lots of open source tools available that were already spoken about in the introduction. There are some best practices that can be leveraged for ensuring that you have a smooth transition to Industry 4.0 and don't repeat the, let's say, the errors that other people already did in the past. Before we take the deep dive, and I will show you how to implement Industry 4.0, I just quickly reason about why should you listen to what I'm going to present. So what kind of experience do we as Fraunhofer IESE have, and what kind of experience do I, Frank Schnicker, have? Since the institute was already nicely introduced beforehand, I'm keeping this slide here rather short. Just to put it in a nutshell, we are focusing on applied research. That means we are doing research and development, and there we are doing it in a way that is very tightly integrated with, on the one hand, big companies, but also, of course, SMEs. And we are very proud in saying that the tools and methods that we are developing are a great fit for both worlds. So that means on the one hand, the big companies, and on the other hand, also the small and middle and medium sized enterprises. And we already have a huge portfolio of Industry 4.0 projects where either we participated, our technologies, our open source tools delivered a great benefit. The point of this slide is not that you can read every single entry, but instead just to give a glimpse in the huge diversity of some projects that we did. Like, for example, the BASIS PLM project, where we focused on integrating various data silos like product lifecycle management systems, ERP systems, and so on and so forth, for creating a consistent data space where all the data is available. And we eliminated redundancies and broke the silos open to ensure that the data can be leveraged without having to fiddle around and figuring out, well, what does this data point actually mean? And is it maybe redundant to this data point? And if yes, which one is the ground truth? This was one of the examples that we did. Another very interesting example is DigiPro for Basis and Open Basis 4.0, where I'm going to speak a little bit about data, where we focused on visualizing data from machines so that you could very easily check from your comfy office chair what is going on my shop floor. Is everything going as planned, or are there some, let's say, values in my virtual cockpit that look like they need some attendance? And there are many more of these projects, but for the sake of time, I will keep it there. Just to briefly also introduce myself, I'm Frank Schnicke, and I'm expert for Industry 4.0 system architectures here at Fraunhofer IESE. I'm very much involved in, you could say, more or less every single Industry 4.0 implementation project that we are doing at Fraunhofer IESE. Of course, I'm not doing them operatively, but I'm keeping my eye on them, that everything goes smoothly, and that we can extract, for example, commonalities, extract best practices, sharpen our tools to ensure that what we are delivering is a best fit for the needs of, as I said, on the one hand, SMEs, and on the other hand, big companies. What I'm doing additionally to that is that I'm coordinating the Eclipse Basic software, which is an open source software, so available free of charge, which enables everyone to very quickly implement Industry 4.0. But I will speak about this later, so I'm not trying to get ahead of myself here. Well, let's start with some, let's say, common use cases that we saw that typically are needed or are the reason, the driving force behind Industry 4.0. The very first one is the plug and play ability of devices, so plug and produce. You can imagine this in a way like the plug and play ability that you have with USB devices today, because let's say if you buy a new keyboard, you don't have to worry about, well, who's the manufacturer of this keyboard, who is delivering me the driver. You just have your USB plug, you plug it into your computer, and since this is a standardized interface, it will just work right off the box. So that means plug and play, you plug it into your computer, and you are ready to go. And one topic that I think is very important here is that we would like to enable companies to transfer this plug and play ability that is known from the USB standard into the world of manufacturing. That means that the vision here is that in the let's say in the long run, you will just buy a new device. If this device is conforming to the standards, and there are some standards in Germany, for example, which I'm going to talk about later. If they are conforming to these standards, you just take your, for example, Ethernet plug. If it's an Ethernet-based communication protocol, you plug it into your socket, into your switch, and the device automatically integrates. And this, of course, drastically reduces the time that is needed for commissioning, because instead of having to stop the complete plant, fiddling around, making sure that everything works, starting the plant, realizing that you missed something, and suddenly you have to shut down everything again, you can just plug it into the wall and you're ready to go, which of course saves a lot of time and also a lot of money. And for this, we have, for example, a very successful implementation that where you can see the quote of Gerhard Schaller, who's a senior manager, digital factory at ZF Friedrichshafen here in Germany. He says, for commissioning a plant with conventional technology, we usually needed 14 days. The other day, it only took us 10 minutes. And while the speed up may not always be that substantial, we still can see that by applying these plug and produce ideas from Industry 4.0, you can drastically reduce the time needed for setting up your plant, for integrating new devices, thus making you more, let's say, competitive. You increase your competitiveness, and of course, you also save time and money. Another use case that I very often see that is addressed by Industry 4.0 is having some kind of process transparency. And I already spoke a little bit about this in the introduction, and that if you take a look at how industry or manufacturing typically is done today, we have a lot of different systems that may or may not be integrated with each other. Most likely, they are not really integrated with each other. And this leads to a lot of pain points, because suddenly you have the same data spread around several systems. It's, let's say, not always one-to-one the same data. There may be some changes, and then you have the data in 3 systems, and each looks a little bit different. And then you have to figure out, well, which one is the right one, because that's not easy to determine sometimes. You also have the issue, if you update data in one system, you also have to update it in other systems. So that means it introduces lots of pain points, because you have to manually keep track of A, that your data is consistent, and B, that the data is, let's say, updated in the same manner, and you don't have to fiddle around and figure out which one is the right data. And why do you need this data? Well, if you take a look at plant optimization, for example, and driven by AI, it doesn't need to be, but with AI, it gets even more important. You need this data. If we take a look at what data scientists are doing, they are spending a huge amount of time ensuring that the data has the right, let's say, quality, in the sense of, is it all in the same format? Is it all, let's say, with the same accuracy, and so on and so forth? They are spending huge efforts there for ensuring these qualities, that if you set up your system correctly, is inherently guaranteed. That does not mean, of course, that you don't need a data scientist, but it means that you can drastically reduce the effort needed for setting up these big data, these AI solutions. And there, of course, we also have a very nice quote of Ricardo Dunkel, who's technical director at the Open Industry 4.0 Alliance, which talks about that by using basics and the asset administration shell, what this is, I will introduce later. For now, you can just think about it like standardized digital twin. They were able to really concentrate on their use cases and achieve their goals faster and more efficiently. And this underlined for him that building and expanding an ecosystem with existing standards and products is key for achieving Industry 4.0. As another very important use case, I think it's worthwhile to mention the efficient lot size one. If you take a look at what is happening today, and the COVID pandemic really underlined this point, and also of course, the ongoing war with Russia, it showcases that supply chains are not stable as they were used to. It can very easily, there can be black swan events that no one predicted that disrupt your supply chain. And yeah, it requires you to react, and it requires you to react very quickly. Because as spoken so nicely in the introduction, if you are not able to react, then you may jeopardize your future, because if your competitors can react more quickly, of course, they will have a huge benefit in the market. And having supporting an efficient lot size 1 enables you to not on the one hand react quicker to supply chain events or disruptions, but on the other hand also enables you to sell products that are tailored to individuals. Because if we take a look at the shifts in society today, we are not taking, let's say, mass production is not the core focus anymore. It's still very important in some points, but if you take a look at, for example, luxury car brands, then they have a vast amount of configurability, and at the other hand, they have a very reduced amount of, let's say, of volume that they are selling. And this combination, low sales volume with high configurability, more or less implies that every car that they sell is unique in some way. And if you can deliver this uniqueness, maybe not on the level of a car, but maybe on the level of other products, of course, let's say the value of this product rises dramatically because it's individualized. So it has more value to me than it has to someone else, and thus I'm willing to pay more. But to be able to deliver this, I need to be able to dynamically reconfigure the manufacturing process at runtime. And again, for this use case, I have a very nice, let's say, quote from Alexander Chaos, who is a team lead for automation and process technology at Sartorius Lab Instruments, which are working in the medical domain, which used Eclipse Basics to implement a highly modular, versioned and distributed product system. And they did this in a very efficient and standardized way. By utilizing the technologies of the asset administration shell and what we as Fraunhofer IESE are delivering, they had very quick success in implementing this and tackling the challenges of a growing diversity of variants. So these are three, let's say, use cases I think that are very representative of what are, let's say, the needs that I see, at least here in Germany. But to give you some more ideas of, let's say, more specific ideas of projects that we did, I also brought, as I said, DigiPro for Basis. What was it about? Well, as you can see on the right-hand side, there are some devices, and I hope you can see it on your screen. There is some white fabric running through these devices. And what this company did is what they are doing is they are sprinkling colored powder on this textile, and they are using heat for melting, or let's call it melting this color into the fabric, and then selling this, of course, to customers. And they had to challenge that they had a very hard time of really checking that everything was going according to plan. So they needed to walk from machine to machine. They needed to take a look at the sensor readings. Was everything correct, or is everything correct? And they had no way of quickly getting the information that something was not exactly going the intended way. And what we did there, and this is what I'm going to show later on, is that we visualized this in a dashboard, so in some kind of virtual cockpit, so that the responsibles there, they, instead of walking from device to device on the noisy shop floor, they could just sit in their comfortable chair in the office, open in their browser a nice dashboard, and directly see, is my plant still going? Is it still doing what it should do? Or is there some kind of temperature reading, some value? Is it outside of the norm? And then directly react to this. A very similar, let's say, project is Basis for Dash, where it was the same challenge. There was simply no easy visual overview over the plant. So that means, similar to beforehand, it was the question, is everything going to plan, was not trivial to answer. Which of course implies that if the answer is no, it wasn't always trivial to see that there was something going wrong. And the later you figure out that something's going wrong, the more, or let's say, the higher the loss in revenue, or even the damage in device and product may be. And what was there very important there was also having some kind of support for mobile devices that, for example, you could use tablets, mobile phones, smartphones for checking that what was happening here. And the idea here was to also support decision making, to enable, let's say, people to really see what is going on, take decisions, and not having to ask every single expert, how is your part going on? Is everything fine with your part? But instead, really having a consolidated view. And to show you that these kind of dashboards don't need to be complicated, very expensive pieces of technologies, I've brought you some screenshots. For example, what you're seeing here is a dashboard that we created that showcases temperature data, which was implemented using an open source software called Streamsheets. So it's open source, it's free of charge. That means you can play around with it right after this presentation. And it's very similar to the tool of Microsoft Excel. So it has very much the same look and feel. However, it enables you to integrate live data from your devices. That means you can very easily use the already well-known approaches that you're doing in Excel, but augment the data that you have to copy and paste and collect manually from all these different kind of systems, and just let's say visualize them here. And if you have it in that way, you can very easily see if something's going wrong. Another very nice example is what you see here, and it was a demonstrator that was delivering brake discs, and this was the demonstrator that was shown at the fair, where the initial contact that led to this presentation was established. And as you can see here, we have a very simple overview, at the same time delivering a very huge value. Because if you take a look at this in the bottom right at this graph, you can very easily, you don't need sophisticated technology. You don't need AI technology. You can very easily see by just looking at it, are the values within my expected interval, or are there some outliers that may be a pointer that something's going wrong? So there are, of course, more points that you can show here, like the overall equipment effectiveness and so on and so forth, quickly pointing out optimization potential. Of course, you can always make it more fancy by applying some kind of big data AI methods, but this is the very next step. And from our experience, even having this drastically reduces, let's say, effort spent on getting overview, and thus drastically increases revenue and the time saved, because you have it here in a consolidated view and you can directly see, is something going wrong? Is everything going according to plan? Another very interesting project is the Basis for Supply Queue project, where we focused on the digitalization of supply chains. Because I guess you know this challenge. If you are buying some parts, you get some documentation. If you're lucky, you get it in the form of a PDF. If you're maybe not that much lucky, you get a nice stack of paper that you have to read by hand. Maybe you have to scan it. Maybe you have to take values from there and transfer it by hand into your systems. And of course, the issue is that everyone has to do that. So that means if there are 10 companies all buying the same part from the same supplier, they are all typing the same information in their system, thus having all the same effort without actually, let's say, generating a benefit for themselves, besides wasting the effort of taking the numbers from a piece of paper and putting them in their system. And what we focused on doing in this project was to have easy data transfer between companies. Because in an ideal world, and this is what we implemented here, if you buy a product, if you buy a piece that you would like to assemble in with your other products, you just get a digital twin of this product, of this piece of metal, for example, that already contains all the data that you need. So, and if your systems are set up the right way, you are able to integrate this data and just save the time manually transferring the data from a piece of paper or from a PDF into your system. Because, as I said, that's something that just takes a lot of time. And even worse, it's error prone. You mistype something and then there's an issue maybe. And what we did there is we looked at the different products, created digital twins for them, and integrated in a way that we could reduce this effort to close to zero in some cases. This concludes some of the use cases and successful examples that I wanted to show. In the next step, of course, I can guess there's the burning question, well, if Industry 4.0 has all these benefits and you said it is implementable in a, let's say, more quick way, if we just take a look at existing concepts and best practices, then what are these best practices? What are these concepts? And before we take the deep dive here, I would like to just briefly talk about one term that I already used, that is the digital twin. Because it's really important from my experience that there is a common understanding of what is the meaning of the digital twin here. Because if we take a look at what is commonly understood, it's, for example, it's a digital description, it's a 3D model, is it a simulation model, is it the bill of material? And I guess if I asked you what your definition would be, there would be a lot of more definitions that you see or that you've heard about what was presented as a digital twin. And since it's such an overloaded term, it's very important to ensure before discussing what we would do with the digital twin, we need to ensure that we have this common understanding. And in the following, I'm going to present some kind of, let's say, classification. It doesn't have, let's say, it's not the single truth. There may be different definitions, but it's still, I think it's one of the definitions that drastically helps talking about what are we actually trying to implement. And for understanding this, it's a very good exercise to take a look at what is happening in the real world and what is happening in the digital world. If we start with the digital model, then we have our real plant and we have a representation in the digital world. But there is no connection between these two counterparts. That means whenever something in the reality changes, I, as a human, have to transfer these changes into the digital world. If I change something in the digital world, I, as a human, have to take these changes and apply them to the real world. That's just the digital model. Now we make it one step fancier. We connect the real world to the digital world. That means, and there the name is coming from digital shadow, the reality is casting a shadow into the digital world. Thus, whenever something changes in reality, it is directly represented in the digital world. Very simple use case here could be, for example, you have some kind of temperature sensor, and this temperature sensor is automatically synchronized with its digital model so that you don't need to walk to the sensor, take the readings, but instead can take a look at the dashboard and directly figure out what is going on. Now since we have the link from reality to the digital world, let's close this link. And if we now have this complete synchronization, so a complete closed loop, a closed feedback loop, this is what we understand here as a digital twin. Because since it's a twin, if I change something in the real world, it's directly applied in the digital world. If I change something in the digital world, it's directly applied to the real world. So complete feedback loop, complete twin. And one example for this would be, for example, having a service-based production where the change on the shop floor is directly shown in the digital model. I can configure services, configure how a product is produced, and this is automatically being configured to the real device, and thus this feedback loop is closed. As I said, this hasn't the let's say this isn't the only truth, but I think it's a very nice way of talking about digital twins and somehow dividing what are we actually taking a look at, because if you have let's say looked at what I presented previously with these virtual cockpits, then the answer there is, well, maybe I don't even need a fully fledged digital twin. Maybe a digital shadow is sufficient. Now, since we have a shared understanding what the digital twin is, one issue remains. Because if right now I would say, well, okay, we have a shared understanding of the digital twin, let's implement it, we would do lots of nice implementations, but they wouldn't fit, because every one of us would do a different kind of implementation of this digital twin. And this is exactly where the asset administration shell comes into play. The asset administration shell, as I said, you can think about it as some kind of standardized or the foundation for a standardized digital twin, foundation for a standardized digital shadow. It realizes a uniform and self-describing interface. it's something that is being standardized right now here in Germany, and at least from the German government and also from a lot of German companies that I will show on the next slide. This is the way to go. This is the digital twin or the implementation of the digital twin that Germany will be using in the future. And lots and lots of companies are adapting this even today. And the idea here is to really have a common understanding, a common representation of what is going on the shop floor, and having it in a standardized interface and having it in a standardized implementation. And if I'm talking about standardization here, I'm not only talking about standardizing fancy diagrams, but really about standardizing technologies. So that means if you would receive an asset administration shell as a JSON file, so just some serialization, you have the guarantee that if you have some tool that is able to process standardized asset administration shells, well, they are directly interoperable. So that means all these kind of different tools that are supporting the asset administration shell are speaking the same language, and your integration efforts reduces very close to zero. I already spoke about it. There are lots and lots of companies that are supporting these, and they are way more than being shown here. But showing all these would somehow, let's say, blow out of proportion this slide here. But as you may see, there are lots and lots of companies there that maybe you are well aware of also in your work in India, or maybe are using every day. And these companies are here in this platform industry 4.0, driving these concepts and implementing these concepts for their own products. Now, now that you have understood that the asset administration shell is, let's say, the foundation for having an interoperable and quick implementation of Industry 4.0, there's still, of course, the question remains, well, if the asset administration shell is such a nice standard, how can I implement it? Because if I take the standardization documents, like 400 or 500 pages of paper, and just put them in my shop floor, then they won't help. You need to have some kind of tools, you need to have some kind of support that enable you to quickly work with these and get going. And here comes Eclipse Basics into play. I already spoke about this in the introduction. Eclipse Basics is managed by me here at Fraunhofer IESE, and it's an open source project together with the Eclipse Foundation. It has an open source license that enables you to use it in your own products. It enables you to use it free of charge and use it in commercial applications. That means you can download it right now, no strings attached, and it gets you going with Industry 4.0. And what are we delivering there? We are delivering several, let's say, software development kits. So software that enables you to very quickly get going and implement it. But it also, and since SMEs are typically, they don't have these big IT departments, we also deliver the off-the-shelf components. These are ready-to-go components that you can just deploy in your IT infrastructure, and that will set up the complete asset administration shell, let's say backbone, that enables you to use asset administration shells, apply digital twins in your companies. And since we are using the standard here, the benefits of Eclipse Basics and the asset administration shell are not only limited to this tool. There's, for example, another very cool tool that is called the ASX Package Explorer, which is also an open source project. It very much enables you to very quickly, using the UI that you see in the bottom right corner, to define your own digital twins and store them in a way that Eclipse Basics is able to process. So that means what you need to do is you need to configure your digital twin here and then put it in the infrastructure that Eclipse Basics is providing, and you have your digital twin that can provide data. Of course, the very next question that then pops up is, well, how do I connect my devices to this nice concept? And for this, we have here with the Eclipse Basics Data Bridge a very simple example, a very simple answer to this. It integrates Opus UA, MQTT, Profinet, Ethernet IP, Modbus, but also Apache Kafka, HTTP REST. It integrates all this into the asset administration shell. And this again is delivered as off-the-shelf component that is very easy to configure, even if you are not an expert of asset administration shells. So that means we have the full stack covered from defining the digital twin, hosting the digital twin, connecting the digital twin with the device it is representing. Now only one piece is missing, and this is the visualization. And also for this, we have available tools that are open source. What you see here, for example, is the AES UI that we are providing in Eclipse Basics that very simply and very quickly enables you to have some kind of visualization of what is going on your shop floor. Of course, you can create more tailored, more, let's say, on your use case, tailored UIs, but this here is a very great starting point of setting things up and getting this very much needed process transparency. So as you see, this full stack of implementing Industry 4.0, for example, for visualization in a virtual cockpit is completely covered by open source tools, from the creation, the usage, to the visualization and the connection to the real device. In the next part, I would like to spend a few more minutes to talk about success factors. So how to successfully migrate to Industry 4.0. Because of course, all these nice tools are really fancy. They really much help, but they don't replace careful planning. And I would like to speak about some, let's say, best practices, about some lessons learned that I saw in companies that they were struggling with implementing Industry 4.0. And that, of course, I would like to present to ensure that you can benefit from these kind of experiences. For example, very much the most important factor in my point of view is planning. And this kind of sounds very obvious. Well, who would implement Industry 4.0 without planning? But nevertheless, it requires a very much, let's say, a strategic amount of planning, because you should really avoid developing island solutions. Industry 4.0 is about integration, and thus you should think about doing your industrial Internet of Things rollout in an integrated way. So that means in the very first step, take a look at where do you want to implement Industry 4.0? Where does it provide the most value for you? But also plan for future extensions. And if possible, coordinate with suppliers and customers. Because if your suppliers or your customers are already using or are planning to use Industry 4.0, and maybe if you're, for example, buying in 5 years a device from Germany, it delivers already the asset administration shell. And thus a compatibility there would be very much beneficial for you and also for your customers. Another very important point is that, of course, the rollout plan should leave room for unforeseen event and changes, because I guess it's true for every project, but especially for this kind of transformation projects, that an application of Industry 4.0 is unforeseen changes can quickly take a project over budget. And another very important point, in my opinion, is do not try to convert everything at once to Industry 4.0. Because this is, at least in my opinion, or what I have seen, one of the highest contributing factors to if something goes really wrong, is that people say, well, we have a system and we would like to implement Industry 4.0. What should the new system do? Yeah, well, everything the old system could do. And suddenly you are migrating lots and lots of use cases. It takes an insane amount of time for implementing everything. And after you have done, you have a big bang rollout that has an insane amount of risk attached to it, because if it does not work, because you misunderstood something, then you're in trouble. And there the recommendation is start with very small selection of use cases, try looking for low-hanging fruits, and develop proof of concepts to strengthen the trust in the technology and really understand how to do this migration. And of course, plan short-time milestones to measure the success of your IIoT rollout to be able to react quickly if something does not look right. There's one let's say, approach that I would like to briefly talk about that is shown here. It's the Architect Industry 4.0 maturity model that very much helps for, let's say, classifying what you would like to do. It classifies use cases, like, for example, visibility. I would like to see what is going on. Yeah, transparency. I would like to understand what is going on. Prediction, I would like to forecast what is going to happen. And adaptation, I would like to react to this and change if something's happening or if I'm predicting that something will happen, which I don't like. And it's very important to think about where is my use case located? And then in the very next step, think about where is my company located? Because if, for example, you would like to predict something, but you don't even have the visibility of the data, of the parameters that you would like to predict, well, you have a very long time to go. And it is very important to identify these quick wins, these low-hanging fruits, and to ensure that you don't select for a very first use case implementation something that is on the domain of adaptation if you're starting in the domain of connectivity. Ensure that every single step along this maturity model is delivering some value, because otherwise you will implement Industry 4.0 for a very long time and have a very long, let's say, waiting time until you can reap the benefits. Another very important point that I think is something I really would like to underline: don't do it-yourself solutions. Use established technologies. The resources for developing it do-it-yourself are really hard to estimate. First, it may look like it will go a little bit quicker because, of course, if you do it yourself, it's perfectly tailored to what you would like to do. But in the long term, it won't save you time. It won't save you money, because let's say if you do it yourself, there is potentially very limited compatibility with the systems of your suppliers and customers. You need specialists because the system is only implemented at your company. So who should know it outside of your company? And thus, future expansions are often very complicated and costly. Last but not least, involve experts. Industry 4.0 is a very interdisciplinary field with a wide range of competencies needed for successful in transformation. You need the people from IT, you need the people from electrical engineering, you need the people from manufacturing engineering, you need the computer science guys, because there's a holistic overview necessary, and it simply isn't sufficient to address these topics separately, but instead you need to focus on the big picture. And especially for SMEs, that's the let's say the one lesson learned that I have. It's very, let's say, complicated to cover every aspect with just the expert that they have. So to put it in a nutshell, involve external experts, like, for example, us, for doing your implementation of Industry 4.0. This concludes what I would like to show. Just to briefly summarize it again, there are lots of best practices and tools available that you could use for implementing Industry 4.0 in your company. They are open source, they are available free of charge, and there are experts that are there for supporting you and covering all these questions that you may have. Thank you very much for your time, and I'm looking forward now to some questions.
Thank you very much, Mr. Shaker. It was a very insightful lecture. Over to you, Ms. Pavani, ma'am.
Yeah, participants, please, if you have any questions, you can unmute and ask your question, please.
Okay, I'll start with the questions. I would like to know more about the plant optimization. How would be beneficial, and what's the role of Industry 4.0 in optimizing the plant?
So in the very first step, let's take a very simple example of optimization. For example, is overall equipment efficiency. If you would like to optimize the usage of your manufacturing devices, in the very first step, you need to know how much are they actually used. Because in optimization, there's always there's the saying you should avoid premature optimization. because if you don't know where to optimize, you may spend lots of time optimizing something, and well, it gets 1% more efficient, but you spend a lot of time for this 1%, where somewhere else maybe 20% in half the time would be possible. And for really being able to doing this kind of optimization, you need to have the big picture, not only focused on a single device. That means you need to collect the data from all these different kind of devices, create an integrated overview, and having this visibility. And this is, for example, something that typically Industry 4.0 delivers.
Okay. Also, if you could talk a little bit more on this lot sized one. What is it all? What is it exactly? And how you have explained us how Industry 4.0 will help into us, but what would be the benefits of the lot sizing principle?
So lot size one, as I already briefly introduced, is of course focusing on producing very individualized products. So that means a customer orders something that is only of value for him or her, like for example, let's say a piece of metal with his name on it. Maybe it's a stupid example, but I think it brings the point rather goodly across. And this is, of course, possible today. This is no issue of doing it today. But it still takes a lot of time, because now you have, if you would like to put this name on a plate, you have to configure something. And if you, let's say, have never thought about this beforehand, of putting a name on a metal plate, then this is very costly to introduce. And now somebody comes and says, well, I don't want to have my name on a metal plate, but instead I would like to have a picture. Yeah. And if your system was only built for putting names on, so words on metal plates, then maybe you can't do pictures, and then you need to adapt. And then the third person comes and wants something completely different that still you would like to satisfy, because they are promising you good money, but it's costing you a huge amount of time and money for doing this change. So that means Industry 4.0 focuses on making lot size one possible in a cost-efficient way, that you can leverage the benefits of it and increase your revenue. Because as I said, you couldn't do this today. It's just so expensive that either you're not getting any, let's say you're getting any money out of it, or that nobody is willing to pay it. And Industry 4.0 helps there by, let's say, integrating the device with, or really the device on the shop floor with the planning, with the optimization algorithms that are on a very high level, and enabling a very quick feedback loop. Because today you could say, well, okay, I need to change this to have pictures on metal plates. I have to stop everything. I need to reprogram my PLC. I need to reprogram my product planning. And in the worst case, your plant has to shut down for several days. And then you realize something didn't work, and then you have to shut it down again to fix the mess. And Industry 4.0 helps by having this kind of, let's say, integrated, very close, very quick feedback loop of the digital twin, and thus also enabling, for example, simulations. It helps for avoiding these kind of nasty surprises, and on the one hand, making changes possible more quickly, and on the other hand, enabling you to predict what will happen if I change this. Because if my simulation, my prediction tells me if you change this, everything will break down, then you can just stop doing it. But if you don't have any prediction, and for these predictions you need Industry 4.0, you will realize it will break down in the worst case the very second you do it.
True. Yeah, the digital twin is one of the core aspects of Industry 4.0, and it plays a vital role in improvising the manufacturing. And given that the open source technology which you have shared, I think it makes it much more easier to adapt these concepts.
Exactly, because as I said, the core here is don't do it yourself. Use existing tooling, and in case of this open source software, it's existing tooling that's even available free of charge. So if you would like to implement Industry 4.0, consider these tools I just showed. And if you don't use them, well, then that's of course a decision that you can take, but then have very good reasons for them. Because if you have to implement all these tools are doing what these tools are doing on your own, it will cost you a huge amount of time and money. And typically, at least speaking from Germany, here in SMEs, here the SMEs don't have the power to set up something as big as these toolings.
Okay. Thank you very much.
Thank you, Mr. Frank. It was a wonderful session and informative also. Looking forward for having more sessions like this month-wise. Now, I would like to thank FAME TN for joining hands with us to organize this session, and a special thank to Mr. Ram for helping us in contacting Mr. Frank and organizing this event. Thank you, participants, for spending your time and listening for this session, and looking forward for having you all in our next session also. We will keep you updated about our upcoming events henceforth. Thank you all. Thanks a lot. Thank you, Mr. Frank. A special thanks to you.
Thank you very much for having me. It was a pleasure.
Thank you.
Have a nice day. Goodbye.